AED has been hit by AI as well. So if you'd like to get your pictures, if you'd like to get your photographs that have been clicked during the day, then all you need to do is, if you have a look on the screen over there and the screen over here, scan, and it will tell you exactly what to do, but you basically scan this, you click your own selfie, and the AED AI is going to find all your photos and send them to you. So you can see exactly how you look while the conversations are going on. So please do that. Another big thanks to the Kirloskas for facilitating the gensets, which has been very, very helpful here at AED. And another plug for the humane exhibition that's going on in the multi-purpose hall. Please do go and have a look at it. There's some, I realized when I went there at lunchtime, 200 million artisans across India. And if you look at how much they earn, it's so sad. But if you look at the quality of the goods that they have there, and many of them are for sale, you will find that there's, as we all know, a lot more to our country, but there's an opportunity to support them as well because you can buy. So, with that said, I'm just going to check on our panel for the next session. Okay. I'll just start with the introduction then. I think we're waiting for one person, and we have one person online. So we've spent the morning discussing sovereignty in industrial and strategic terms. We looked at economic development and health. We looked at the defense industry with Baba Kalyani as well. Now we're going to examine one of the domains where sovereignty is being redefined in real time, and that's linked to what Baba Kalyani spoke about earlier, high technology in defense. When we speak about the future of warfare, it can sound abstract, but it isn't. In our own region, recent cross-border operations, you know where, demonstrated how unmanned systems, precision strikes, integrated air defense platforms, and real-time command networks now shape strategic response. These were fused systems, surveillance, interception, data, and decision-making operating actually in compressed time frames and literally real time. Globally, the Russia-Ukraine conflict has also reinforced the same lesson. Drone warfare, AI-assisted targeting, and network-centric battle management are no longer experimental, they're actually operational. And military expenditure worldwide has surged to record levels, but the deeper shift is qualitative. Conflict is increasingly defined by the integration of sensors, softwares, and systems, by the ability to process information faster, act faster, adapt faster than your adversary. And this raises difficult questions. How much autonomy should machines have? What remains uniquely human in warfare? And where does India stand, not only as a user of advanced systems, but as a builder of them? And what does that say for Asia? That's a discussion we're now going to begin in high technology in strategic defense. I'd like to invite the chair of this session to the stage. Please give her a big round of applause, Dr. Sangeeta Kale. That should be an afternoon big round of applause. You've eaten. There we go. She's a leading defense technologist and professor at the Defense Institute of Advanced Technology, the Indian Ministry of Defence's premier engineering and research university in Pune. We also have on the panel for her, or with her, Manish Bhardwaj, who serves as a technical advisor to the chairman of India's DRDO organization, the Defense Research and Development Organization, the government agency responsible for indigenous military research and defense. Can we welcome Manish to the stage? Welcome, Manish. We also have Professor Balakrishnan, who leads computational aerodynamics research at the Indian Institute of Science, Bengaluru, with decades of work on high-fidelity fluid dynamics simulations, foundational to aerospace design, hypersonic research, and next-gen defense platforms. Professor Balakrishnan, welcome. Online, we have Dan Yachin, who's the senior researcher at the Critical and Emerging Technologies program of Mind Israel, where he brings over 20 years of strategic research experience in emerging tech and national security, helping bridge deep tech insights with security policy debates. Welcome, Dan. Good to have you here. And you're getting a big round of applause. And finally, we have Brigadier Retired Viresh Srivastav, Senior Vice President at Business Integration Systems India Private Limited, who combines 3 decades of Indian Army service with private sector leadership in defense integration and capability building. And he's a vocal advocate of self-reliance and tech-driven defense industry growth. Can we please welcome Brigadier Srivastav? Big round of applause. Dr. Sangeeta, the stage is yours.
Good afternoon, everyone. And I know that our panel has a difficult job after a very good lunch that you have had, along with Puran Poli and everything. So, but I have to also thank the organizers for having this session at this point of time, because it itself is a very interesting discussion, and I'm hoping that we all of us together will keep you all awake. Technology, as you know, is advancing at a very, very rapid pace. In the last 10 to 15 years, whatever we have seen happening in technology has been extremely at a very high value, and at a very fast rate it has improved. These are scientific innovations. These are also related to the disruptive technologies and the technologies which have been brought in the market because of the cooperation, collaboration and innovation in the entire world and bringing multiple countries together. If we think of some of the salient technologies that we all have witnessed in a very small period of time, then we have artificial intelligence, quantum technologies, cryptography, we have digital twinning. We have heard a lot of these discussions since morning. We also have missile technology, hypersonic technology coming in. A lot of things have been done in satellite communication, 6G, 7G technologies are coming in a big way. And of course, data science and many other things, which includes also a radical improvement in material science, in metallurgy and materials, which we heard in the morning by Shri Baba Kalyani ji. All these have related to the semiconductor technology, which has been improved a lot, and so on. However, when these have been advancing and when they are getting matured, we also find that there are many clashes and many competitions which go on as the technology goes on developing. For example, you have large amount of data threat which is related to cyber security. It is very, very pertinent that these cyber security and cyber crimes are seen by the common people like you and me, but it makes a huge impact when you consider defense security. Along with this, we also have a lot of tussle, lot of competition. When you think of data storages, when you think of servers which are getting installed in different countries, there is a lot going on there. There is also a struggle over rare earths, and there is a kind of a supremacy which people are kind of, commanding and demanding, depending upon the place where the rare earths are and the technology of purifying them exists with some country or whether it does not. There is also competition on space to accommodate more and more bandwidth, which is related to high-speed communication, and therefore there is also a tussle there, which you can see as the technology gets advanced. When we think of all these things, we also think of the geopolitical scenario, which is changing very fast and it is becoming extremely volatile in the current times. As it becomes volatile, it is very important for every country to get geared up and be the best from the science and technology point of view, because if they are not, then literally they are supposed to perish. So in which case, therefore, it's very important that the national defense becomes, it's geared up, it is becoming better. It can become better by themselves, or they can become better by collaborating with other national institutions, other different countries, so that they are at the edge and they are not susceptible to any kind of attacks from any other countries. I'll just quickly give you the salient areas in which the entire world is putting their efforts, typically related to defense. The first is cyber warfare. We all know about it. The more the digitization we do, the more the digitization is done by the defense sector and the army sector, the more are they prone to the attacks in which the data can be easily taken away if the security is not in place. Artificial intelligence. So it's basically a decision-making system. These decision-making systems, we have to ensure that they are totally remaining in the control and command of the original country. Digital healthcare, we have heard a lot in the very, just the talk which went by, the discussion which went by. Digital healthcare and automation in the healthcare is also important. It's also important related to a soldier at the war front. Hypersonic missiles, we see a lot. I'm sure we'll hear a lot also from the esteemed panel here. Internet of Military Things is called as an IOMT. This is also an area which is developing very fast. And these are related to the military network and the way in which military technologies are connected to each other and they talk with each other. Li-Fi communication has been in the talk for a very long time. That is fly-by-light, as they say, which is related to an alternative to the RF communication and trying to use light as a communication medium. And that's something that people are working on. And now we can see with the quantum technology coming in a big way, we can see Li-Fi systems also coming to reality in some point of time. Virtual reality is another area in which good amount of work is being done. Directed energy weapons, you can actually see them today when you see the warfare around. As I told you, we also have the geopolitical paradigm shifts going on, and therefore we need to know, we need to understand the strategies which go on within a typical country or within a particular country to see to it that they remain safe, they remain secure, and they are also remaining advanced in their own technologies. I have just collected some examples of major incidents that I would like to share with all of you on high-end technologies that have been used for strategic defense and combat. So the first example is something which all of us are well aware of. We have Air Marshal Bhushan Gokhale here, sir. I want to start with his example. He was the one who has inducted the Akash missile into the Indian Air Force along with Dr. Prahlada, who was then the missile technology head from DRDO. So he is the one who has inducted Akash missile, which has seen huge success during Operation Sindoor. So I think we all should give him a big hand. Also, along with the collaboration with Hindustan Aeronautics Limited, we have a BrahMos missile, and this missile, there was a challenge to fit this particular missile as a payload on the Sukhoi aircraft. And Air Marshal Gokhale, sir, has actually designed it in such a way that the engineering was done in such a way that they were able to launch it as a payload on the Sukhoi aircraft. And after that, it became an official payload for all the aircrafts, for all the encounters that we see. So again, the architect was Air Marshal Gokhale. At the end, internationally, when you see Russia and Ukraine, they have incorporated the first-person view drone systems which are used in military tactics. This is something which is very recent. which locates the army tanks at a very high precision. Israel will know more from our panel member, but they've used technological edge and including AI-generated target recommendations to attack Hamas. US military has used Claude AI, which is a product of Anthropic, while they have done a recent attack on Venezuela. Much has been talked about this also when we had the initial discussions. Operation Sindoor will know more from our panel, but the loitering munitions have been one of the best operations which have been done for target identification against the terror bases. Swarm drones is a very popular technology. Russian military has been able to find out an option to the Starlink project, which is of Elon Musk. Therefore, they have tried to see that in spite of you not having an access to the Starlink communication system of satellites, they were still able to do the communication for their own warfare. So there are many such examples in the recent and in the past. However, we need to start with the discussion, and let us start right away. So the first question comes to Dr. Manish Bhardwaj. Sir, you have been in the system of DRDO. You work also as a chairman of, you are also an advisor to the chairman of DRDO. Can you tell us more about the high technology that is used in the strategic defense, especially from the DRDO's perspective?
Thank you very much, and very good afternoon. I'm thankful to PIC leadership and team PIC and Ambassador Gautam Bambawale for giving me an opportunity for this session. So with this, I will try to give you more satisfying answer, but you know, the strategic defense by itself is a very closed door community and affair. So, but still, the high technology and the vastness of the social media, which has reached to everyone, most of the discussion which are in closed door, but they come out, and it becomes a public affair in the national discourse. So, if you talk about BrahMos, BrahMos is a joint venture between DRDO and NPOM Russia, and it is a JV kind of affair, and but at the same time, it is having a very confidence in each other partnership. It is mostly a partnership. It was not a licensed production. So coming to the high technology area, whatever BrahMos has been designed and developed in Indian soil. Now the next version, which is likely to come, is called BrahMos NG, which is lighter and it is more lethal, and it is having a better range. Similarly, the program is also envisaged for BrahMos 2. Till now, it is in the it is working on a different speed, but BrahMos 2 will be having the hypersonic ability. So these are the programs which are offering. Now, coming to the high-tech technology area for strategic defense, as ma'am has already covered most of the things, but hypersonic is the new buzzword for us, and DRDO has come out with the LRSAHM missile, which is long-range anti-ship missile, and it has been recently showcased in Republic Day parade also. So it is more than Mach 5, and it has been developed and it has been tried and tested also. Then coming to the new age aircraft development program, the MCA project has already been sanctioned, Advanced Medium Combat Fighter Aircraft, which is again DRDO has taken an initiative, and it is working well, and we will see mostly somewhere in another 2 to 3 years the first prototype of that. Then coming to the quantum basically quantum technology, DRDO has come out with a new concept where the young scientist labs, 5 new young scientist labs have come up. In one of the lab, mandate is DYSL quantum technology, which is right in the Pune itself. And they are doing very well. And quantum key distribution, quantum communication, these are the major tasks which has been accomplished. Quantum sensing, quantum materials, they are offing, and it is being under development stage. Coming to now the AI part and the drone technology, which was very well being seen in the Ops Indoor also. The drones, in fact, I put it in this way, DRDO has done their bit for a bigger drones, which are considered to be a HALE and male class drones. But the real game changer was the small drone and the drones which are having a loitering capability, giving a loitering ammunition capability to Indian Armed Forces. So that also is being taken up with the private industry, and of lately DRDO has come out with various schemes where the private industry, startups and MSME can collaborate and work with DRDO under various models. And coming to the cyber part, we have a specific dedicated team which is working for a cyber security. And we have come out with the hardened OS, which is basically used in DRDO lab. We have our own network, so we don't rely on on internet itself. We have our own network. So these are some of the major technologies which has promulgated and taken up by DRDO in recent times.
Thank you, sir. So my next question goes to Brigadier Viresh. Since both of you sit at the two ends of a chain, so having known the technologies which are developed by DRDO and the ongoing work that is being going on, and with your experience of around 35 years in Indian Army, what do you think are the technologies that has affected the conventional art of war fighting? And what technologies do you feel are the need of an hour at current point of time on which DRDO should focus on, or any defense research should focus on?
Thank you, ma'am. Good afternoon to everyone. And thanks to PIC for giving me this opportunity to sit here with such learned people. And I heard the previous discussion also. Very, very enlightening. So, ma'am, it's a very interesting question you've asked. In fact, it's a very nostalgic question when you say how the art of warfighting has changed. So it takes me back to when I was a single paper of June '92. So there's been a drastic amount of change in how the technology has shaped the warfare of today. And second point, I would just compliment you of using the word art of warfighting. I think that's a very important word you used, art. Warfighting is not a technology or not a science or not a methodology. It's an art, how you use your brain, how you use the technology. I'll come to it subsequently. So what has happened over the period of last about 35 years, which I've seen, and there are some very senior veterans sitting here, Air Marshal Gokhale, who's a veteran of 1971 war. So pardon me if I go wrong somewhere. But what I've seen in the last about 35 years, firstly, I would say the speed of operations. That is one. Today, the time from getting an input to striking a target has reduced drastically. So that is because of the technology, because of the inputs which we get, which are much faster. Second is, I think we have from being a mass destruction concept, we come to a precision destruction. And we've all seen it during Ops Indoor. Earlier, the concept used to be 100-gun concept, plaster the enemy defenses, don't worry about the collaterals and such like thing. Today, we've seen that we may not have a war which is, although something is probably brewing up in our neighborhood, but definitely today we'll not have a proper full-fledged war. We may not have that. So we have to be more precision-oriented. So towards that, you already mentioned a few things like the PGMs or the precision-guided munitions, the smart munitions, which have come in. Next sticks, I think, is about the info warfare. Now, info warfare, I will cover the cyber aspect separately. So as far as the info warfare goes, today as a commander sitting in the operation room, I am much more armed. I am much more informed. I am sitting, if I put it this way, I am sitting in the battlefield, and as if I am viewing the battlefield in the first person. Take your mind back to Mahabharata, where the Sanjay was relaying the battle to Dhritarashtra. So that is what has happened as far as the info warfare is concerned. The info flows fast, so you are able to beat the decision-making cycle of the enemy. Yes, info comes in quite a lot of quantity. I'll touch upon how it is being handled separately. So the fog of war has become, if I can say that, it has become thinner, although it has not disappeared. The human intervention definitely has to be there. Earlier, we used to have the concept of fighting by night, and so that you can achieve the surprise, and all our attacks used to be planned in the night. But I think that concept is gone. Today, the night has turned into day. The amount of the night sites which have come in, the sensors which have come in. So there's no night. There's no division of a night and day war. Another thing which I feel is about the cyber aspect, which you also alluded to when you were talking. Cyber is, and a very important point you made, it may be a cyber attack for our civil community or for this thing, but for defense, it's a war. So whatever data since I've worn the olive green, I'll always speak in offensive terms. If we are able to get into his networks, get into his GPS jamming, probably jam his server networks. So that is what is the thought process, and that is what is changing. AI definitely, last but not the least, AI definitely has made a tremendous change. It is moving in parts. It's solving that whatever I mentioned, that commander who is sitting in the operations room is having too much of info overflow. So this is where the AI is helping him to segregate this info, to get him the correct info, to give him the correct picture. The battle picture is painted that way. We've seen drones, and you just mentioned about the PGM, also the LMs, or the loitering munitions. I think drone technology is taken off in a very big way. And the loitering munitions, the kamikazes, the speed, there are drones which are today flying at 800 kilometers per hour, difficult to intercept, difficult to do anything. So these are the technology which I feel, in fact, what has happened is, if I can just sum it up in one line, today it doesn't matter that how large a force you have, but what matters is today is how you have been able to integrate the technology into your forces, and how you've been able to apply that technology. The second part of your question was, in fact, some part you've already covered, is what technology should come in or should come in future. I think after seeing the Op Sindoor, one thing which is very much of priority, things have started moving in, is the counter UAS system. That is very important. That was what was felt. The need was felt during Op Sindoor. And I was, during the lunch break, I was speaking to Air Marshal Gokhale, and I was thanking him. In addition to the BrahMos, there is a system called as IISc, and Akash missiles. He's been an architect of that also, which was a major mainstay in destroying or in destruction of the enemy drones. Next, of course, Manish also spoke, is about quantum. Quantum technology, there is an Indian quantum mission which is going on. There is a document released by the CDS, I think last month, if I'm not wrong, on 22nd or 23rd of January, about how the military has to approach the quantum or take in the quantum. So towards communication is one part, Li-Fi you already mentioned, towards ranging and towards picture painting is the next part of the quantum technology. We need to look at cyber data, and this is I'm talking of in the company which I'm working now. Data is the next gold mine. In fact, I've just posted a blog also on LinkedIn about digital borders. While physical borders are there, but now there are digital borders. How do you protect your data? So that is one very important aspect of cyber. So how does Indian Army or Air Force or Navy or any of the forces or the DRDO itself protect that data, the cyber aspect has to be there. You mentioned about Li-Fi, I've already touched upon. And, drones. Probably we require to mature in our technology of drones. Those, although we've gone in for various quality of drones in terms of hail and mail, which was mentioned by Dr. Manish. But we require to think of drones which are fast flying, difficult to intercept, doing multiple tasking, such like thing. Yeah, I think if I come down to specifics of ammunition and specific of weapon, I think DEWs is the next thing in line. And of course, you mentioned about hypersonic. I think that is where we require to work at. And of course, there's one more thing. It's the protection. The individual person who's there requires protection now. For that, the body armor is already coming in. The exoskeleton is coming in. Drones are started doing your job of your minefield breaching. You've got the UGVs coming in. So all these things are happening. I will not speak about the autonomous weapon system because of the ethical issues, but yes, that is also one thing. If I speak purely as a military man, we require to think about inducting the technology of the autonomous weapon system with probably human in the loop.
Yeah, thank you. As far as I know, actually there is a good amount of work going on humanoid, which is a human robot in which there is an artificial skin, and there are a huge number of sensors which are being installed on the same as biped and quadruped kind of a robotic system which can go into the warfare without human intervention. So there's a good amount of work, I think, going on there as well. Also on swarm technology, in which there is a big technology coming in. Now I'll have the next question to Dr. Dan. Can you hear us?
Yeah, I can hear you.
Yeah. So Dan, thank you for joining us online. And also from Israel, since everybody here knows that Israel is at the forefront of defense technology and the strategic systems which are developed therein. My question for you is that based on your recent experiences that you have from the Middle East, we know that Israel is known for its incredibly short development cycles. So how do you kind of manage the feedback loop between the people who are, the soldiers who are at the war front and the engineers who are working at the back end to ensure that the technology transfer happens fast and you are able to develop a cycle very fast?
Yeah, thank you. And just let me start by saying that it's a great honor for me to join you today. I was looking forward to visit you and share the stage physically. But unfortunately, as you are well aware, the situation in the Middle East is volatile, so we have to take precautions. So I'm joining you remotely. Hopefully next time we can do it physically. This is a great question because feedback loop has actually become one of the keys for winning the modern battlefield. And in Israel, we were able to significantly shorten the feedback loop because the main reason is that Israel, as you know, relies on large-scale reserve forces. So many times the soldiers on the front lines, and the people who engineer the systems are the same ones, because it's the people on the battlefield are engineers in the civil lives. So beyond that, we were able to achieve a new kind of deployment model, so to speak. As you know, historically, defense development was a linear, cumbersome, lengthy waterfall process consisting of defining the requirements, design, prototyping, and then deployment. And we replaced that in Israel by what we call spiral development model. So those engineers from defense contractors or startups that were in the battlefield could see the failure points, for example, of a drone or a sensor in real time. And because of that, during the recent conflicts, they were able to change, for example, the threat signature of enemy drones very quickly. And this fast feedback loop allowed for software-defined electronic warfare patches, for example, to be pushed to frontline units sometimes within 48 to 72 hours, which is a huge improvement compared to what we had before. And later on, many of those new solutions that were developed to meet the changing needs of the battlefield were the basis for hundreds of new defense tech companies, startup companies that continue to test and fine-tune their products in ongoing operations, which unfortunately we have them every now and then in the Middle East. So it's a great test bed, so to speak, for those technologies. So this is the Israeli model, if you will, of resilience, where the battlefield is the lab, actually.
Okay, thank you. Thanks a lot for your answer. Professor Bala, since you have a very strong background in aerospace engineering and also have computing technology as your forte, can you throw some light on the technologies for strategic defense, in particular, typically related to computing technologies, how they can help in strategic defense?
Thank you. Going by what Krishna Ella said yesterday, I am the elephant in the room. Okay. Technologies for strategic defense. This is slightly different from what the other speakers were talking about. They were talking about the systems, but what I would like to mention is about what goes in the design of those systems. I think that's what we are going to look at. So when you say computing, it gives me very fond memories. I know I'm very happy that I'm sitting and talking to you today in Pune International Center, because way back in 2007, 2008, we had a first-hand supercomputing experience at Pune. We had a supercomputing machine called ICA. I think several of you may remember that, in Computational Research Lab, CRL, which was a privately funded computing lab, unlike most of the other supercomputing initiatives at that point in time, worldwide. Okay, most of them were government funded. Even today it is government funded, except for few of them. So when we went there, for the first time, we saw that, we had developed a tool, computational tool. We are talking about products today. So we have a product, Dept product, which is used for the engineering analysis of the stealth vehicles, strategic defense vehicles that we are talking about. So we could see seamlessly our code sort of scaling over 14,000 cores. That was some kind of a great awakening for us. We very quickly realized what, I do CFD, computational fluid dynamics. So what CFD can offer in terms of design of aerospace vehicles, okay, for the first time. Until then, I think we were working with some 128 processors of Pentium 3 and so on and so forth. So it was a great, I would have really wanted that story to have become a success, the CRL story, but that's a different thing. So just to put the story in context. So when you say computing, there are two aspects to it. One is the hardware and the other one is the software. And what is most important for all of us to note is that both these technologies were denied to us, because I think we were always been talking about, right from yesterday, we have been talking about technology denial. There's a clear example where both these technologies were denied to us soon after the Pokhran blast, right? I think things became normal in 2002, 2003 period, but nevertheless, it's important to take note that it was denied to us, right? So we are now living in a time where even stable things like banking system could actually be affected by the conflicts. If somebody thinks that these technologies are not going to be denied in future, I think that would be foolish, right? So it is very important for us to sort of start working on it. It's not that we are going to have our own technologies tomorrow, but we should also not wait until the time these technologies are denied, then say that, okay, we will get started. Should not be the case, but because to me as such, it's a reality. It is going to be denied, if not today, if not tomorrow, definitely day after tomorrow, you will have a scenario where these technologies are denied, So on the hardware part of it, I think we need to really seriously think about semiconductor fabrication. I'm glad that we have at least started talking about it these days. Many of us may remember that we had a facility in Chandigarh. There was a fire accident and we lost it, and nothing was done after that. Nothing was done after that. But I am glad that we are talking about it today. And similarly, about the products. There is a great dependence on products which are all, which all have the roots in the foreign countries. And today in the morning, I'm glad that one of the speakers did mention how these products actually, very stealthily sneak in to the Indian design cycle by the way of saying, projecting more than 60% Make in India component. I think these are all extremely critical things. So in that context, I would like to tell you that this is more reassuring for me and also possibly for many of you, that what we have developed in the Computational Aerodynamics lab in IISc is a software product. Exactly the same question was there when I graduated after my PhD. Like people used to say that Bangalore is Silicon Valley of India, right? Now, they started looking at what do we have really in terms of a product. There's nothing like a product. But fortunately, I had, the company of my own excellent students, right, from IISc, with whom I could work and develop these products. And we incubated a company out of IISc in 2007. And I am very glad to say that that product is being very extensively used by the defense and the science space labs in the country. And in fact, today in the morning, Baba Kalyani was there. The projectiles in his system are designed using our product. Okay, so I'm very glad about it. I'm very glad to say that, because I'm not saying that this product should become commercially a success. Of course, I would love that scenario, but more importantly, the success of this product is actually sort of translates into an ecosystem and gives a lot more confidence to many people to venture into such development. Because when we look at aerospace, I think we look at the systems, okay, but what goes into those systems are equally important. In fact, there was a recent article in Swarajyam which was reflecting on this, right? So this is about the computing technology, but very quickly I will also, because I'm also closely working with the defense labs, the other shortcoming, okay, is that we do not have test facilities, okay, for many of our defense systems. One example that I can actually give is the gas turbine engines, because if you look at the media, they are very negative. Okay, I'm very sad to say that they are very negative. They will say that oh, you have a DRDO lab working for last 30 years, nothing has come out and all that. But if you really talk to them, you will know the pains of these labs go through. I think our Manish ji would sort of can actually throw more light on that. The amount of time we, in getting these testings done in various places, could be Russia, right? I think this is phenomenally high. We do not have a high altitude test facility. For something like a gas turbine engine, these test facilities are extremely critical. If you really think that these technologies have to mature fast, we should also work on these test facilities. Of course, of late, I know that we have good test facilities in terms of trisonic tunnels, which have come up both in the DRDO and the ISRO framework. But nevertheless, I think there are a lot more that we need to work on. So I stop there in terms of the technologies. Yeah.
Thank you. I also hope that this India Semiconductor Mission will make a difference, because we have now fab labs coming up in Assam and I think also in Gujarat and so on. So continuing with what he mentioned about the students and in the companies, I just want to ask you, Dr. Manish, that we have, there is a good amount of privatization, as you can say, of the defense manufacturing. it has happened in last 10, 12 years or so. So this Government of India's flagship initiative, which is defense corridors in our country, what are the major initiatives that are being taken up for the participation of academia and industries in the defense sector?
Yeah. So, in 2016 or 17, I think, in the general budget, the government of India announced one major initiative to promote the defense manufacturing and industry in the country. One is to make the defense corridors. So there were 2 defense corridors which was announced by, I think, that time Mr. Arun Jaitley, Honorable Finance Minister, was there. So one defense corridor was announced in UP Defense Industrial Corridor, and second was announced in Tamil Nadu Defense Industrial Corridor. So these 2 industrial corridor has a mandate to promote the MSMEs, startups and small industries and the large industries also for giving a impetus to defense manufacturing. So I was fortunate enough that I got posted in Lucknow for 3 years to start this mission. And I'm happy to say that when I landed there, immediately after that, COVID started. So in that difficult time, I started conceptualizing, and I started talking to IIT Kanpur, then IIT BHU also. And then after a long deliberation, we came out with a model that, if we have to promote a defense corridor through DRDO in the country, then probably I conceptualized that a facilitation center is needed. Now, this facilitation center has got a 6-arm, basically, which is meant for the first arm of this center is testing, what you suggested, testing and validation center. The second arm will be for doing the Industry 4.0 work for additive manufacturing. Third will be design and simulation, because I found that many of our small-time defense fabricator and manufacturer who get associated with DRDO projects, they lack costly tool for designing the things. So they come to us, and we have to struggle and get it designed. So I thought the design and simulation center would help them in cultivating that. So that was the third arm. The fourth arm was to incubate. It is required that the small-time MSMEs and startups, they get a hand-holding support for incubation of their idea to become a mature industry. So an incubation center was proposed. And the fifth and very important, which I found in the context of UP, that skill development is highly essential. Because after talking to many industries there, during COVID time it was most on the virtual side. They say that we don't have a people who are industry ready, who are passed out from ITI and they are industry ready for a shop floor working. And whereas when I started talking to Tamil Nadu people, they say, no, we have plenty. So it is a kind of an area dependence kind of requirement. That UP is lacking in the skilled manpower who are not very equipped with running the machines on the shop floor, whereas in Tamil Nadu it was not like that. So they have different problems. So skill development was one center which has been proposed. So skilling, again, there it was a massive requirement actually, and a small one entity cannot fulfill everybody's need. So what I did, I talked to IIT Kanpur and IIT BHU and cultivated a model where they will train the trainers. And those trainers will go back to ITIs and diploma institutes to train the other people, who will be in terms ready for defense manufacturing. So that is how we run that program. And the last and very important center of this unit was the business development unit center. Now, I have observed that many of the MSMEs and startups who want to venture into defense manufacturing, they don't understand the lingo of what MOD proposes. They don't understand. They say, what is GSQR? What does it mean? So there is a wide gap. So to make them understand and to promote their hand-holding, that business development center was proposed so that they interface well and they gel well with the MOD's language, and whatever they understand. Half of them were not knowing how to interact on GEM or DefProc, or how to fill that form, how to do a compliances, what is the certification requirement. So there is a number of activities which they were lacking. So this center was the backbone. And this inspiration, I got it from the railways. I found Indian Railway is the oldest organization which has not been disturbed or recalibrated or refurbed apart from Indian Armed Forces. There, they have a commercial section is different from the other sections. So their job is only to do the commercial business and marketing. They have a very separate things. So from there I could understand that in defense also, there is a need for having such kind of center which can deliberate on these kind of issues of MSMEs and startups, so that they come onto this side of the table. So with this center, this center was proposed, and it has been very well organized, and it has been inaugurated by Honorable Raksha Mantri and Chief Minister of UP, and 3 years back, and now it has started functioning. So this is one model which has come up well, and it has found a mention in some of the government appraisals also, that this is a model which can be taken up further. So similar model I am proposing for the Tamil Nadu also. And with this, some 30,000 crores rupees of investment has come into the UP. Because of this center facilitates and interact, and the industry comes and push their ventures into defense corridor.
Okay, thank you. I think there is
One
also...
more thing I wanted to tell about the semiconductor part, sir, which you have mentioned. I wanted to tell that DRDO has done well in semiconductor business also. Now we have come out with the technology of semiconductor 2.0, which is a next generation semiconductor of gallium nitride. So GaN is available for manufacturing, and it is being done by one of the DRDO lab called SSPL in Delhi. So TOT is available. If Indian industry wants to venture, we can do that.
Thank you, sir. The next question goes to Dr. Dan. In Israel, everybody knows the presence of Iron Dome. People are much interested to know more about it. The way in which it was there when it was kind of developed, and what are the ways in which it has been advanced to cater to the recent defense requirements. Can you throw some light on Iron Dome, please?
As necessity is the mother of invention. And just to give you a sense of the scale of threat that Iron Dome was designed to cope with, the system is now, quoting the recent statistics, intercepted over 10,000 threats over the last 15 years. It's a huge number. I'm just talking about short-range missiles, which Iron Dome is designed to handle. I'm not talking about the large-scale ballistic missiles. These are other systems are dealing with. And we keep upgrading and making the system more sophisticated and fit to handle the evolving threat landscape. And in 2026, it actually rolled out new features. And one of them is called advanced sensor fusion, which allows to distinguish between, for example, a dumb rocket or a rocket that is about to land in an open field with no population whatsoever, and between a maneuverable UAV, for example. And the new features allow it to do so with unprecedented precision, which is important because of what we refer to as ammunition economy. And the real interceptor of the Iron Dome system costs around $50,000 US. So multiply that by 10,000 interceptions, you will get huge numbers. So obviously, this is something that can be sustainable over time. And the game changer here is the newly launched Iron Beam high energy laser system, which is now being integrated as a complementary layer to Iron Dome. So compared to the cost of a kinetic interceptor along the lines of the Tamir interceptor of the Iron Dome, a laser shot costs roughly between $2 to $5 US, which is basically the price of electricity. So this system is not replacing Iron Dome. It's a hybrid. It creates a hybrid shield. It is powered by AI-driven command center, which decides in milliseconds whether to launch a kinetic interceptor. For example, when the target is outside the current range of the laser system, or in situations where we are facing heavy weather conditions where the laser doesn't function quite well yet, or it can decide to launch a laser shot, which is ideal for handling short-range rockets. And another major benefit for the Iron Beam system is that it enables us to move toward a silent interception doctrine. This means that threats are neutralized before they even cross the border, potentially eliminating the need for sirens in certain sectors. But looking ahead, the combination of Iron Dome and the new laser system, together with other systems like the HETS missile and other systems that are currently under development, it should provide us an unprecedented shield against a variety of threats that keep evolving. I know for a fact that some of these systems are already being tuned to handle maneuvering hypersonic missile, and we made adjustments to the Iron Dome system to better handle drones, which was a major issue during the beginning of the war. So whenever, as I said before, because of the fast feedback loop between the engineers and the soldiers on the battlefield, we are able to update and adjust the system dynamically to evolving threats, and that's the main power behind it.
So just a connecting question to the earlier question, Dan, is this that how do you use the multi-layered defense integration, considering the recent 2023 encounter that you had, and there was a black swan which was related to the concept of false sense of security. So how do you see multi-layered defense integration in this context?
Yeah, you're absolutely right, because the technology failed because it was used as a replacement, in a sense, to human judgment, and we can't do that. The Black Swan event proved that sensor can be blinded, and AI can be spoofed by low-tech tactics. So the biggest lesson we learned is the importance of having a human in the loop. And we can see that, for example, in urban warfare, where autonomous quadcopters like those developed in Israel and elsewhere now perform what we call pre-entry mapping of tunnels and buildings, and they use simultaneous localizations and mapping to create 3D tactical maps for soldiers, which they can see on their augmented reality goggles, for example. So soldiers in the battlefield can analyze the threats and prepare accordingly, And this is a significant game changer. And as for multi-layer defense, well, Israel uses AI systems that process intelligence at a scale no human could. For example, the Gospel AI system, which has been published, is one of those systems. But the 2026 shift that we see today ensures that a human commander makes the final kinetic call, thus preventing, the automation bias that leads to strategic blindness, as we witnessed on October 7th. And looking ahead, I think that under any circumstances, AI systems should never be allowed to pull the trigger, so to speak. This should always remain a human decision. It's really important. We cannot fall in love in technology and neglect the human side. It always has to be in the loop, making the final calls. That's the main lesson we learned.
Yeah, very well said. Thank you, Dan. Thanks. We have a very small time left. I will go to Brigadier Viresh. Can you just give us the roadmap of high technology for strategic defense? Can you quickly throw some light on that?
Yeah, ma'am, you alluded to me during the lunch break that probably you'll ask me this. So, what I did was I just Googled for TPCR. TPCR is a document, technological perspective capability roadmap for the defense for the Indian Army. This was released in 2025 and covers the period from 26 to 2035. It's divided into 3 phases, basically near-term goals, then mid-terms, and then the long-term. So I jotted down a few points because it's hard to remember. The first phase is the current year and the next year is foundation and integration phase, which includes combined, joint, all arms command and control. That means integrating the complete network and all the sensors into one network. There is an interesting term called as ZTA, Zero Trust Architecture. That means every individual, every device is doubtful, or needs to be, doubtful is the wrong word, every individual, every device needs to be authenticated. Of course, it's something about agentic AI and generative AI. Digital twins. Now, this is something, if you've been following the news, for the Vizhinjam port in the south, in Trivandrum, the digital twin of the Vizhinjam port have already been developed by a company called Sahana Defense System, and this was yesterday, I read somewhere. So digital twins is one more thing which requires to come out in phase 1 in terms for saving our efforts into going into a lot of exercise in war games and such like things. Phase 2 is from 28 to 29, basically advanced capability and deployment, hypersonic we spoke of, autonomous weapon systems, DWs, and interesting thing called as collaborative combat aircraft. That's why in my first part I mentioned there are drones which are flying at 800 kilometers per hour. So integrating the fighter aircraft with certain drones. And phase 3, which is the last one, is the strategic frontiers. Basically into quantum. When I say this is what I've just, ma'am threw a surprise to me, so I just got it from there. But the phases can be switched on. Quantum can come earlier. There's already something happening on quantum. Then, of course, the space militarization in terms of using the satellite constellation for communication and space-based missile defense. Energy and material forms part of this. So the objective is to have a deterrent superiority and credible strategic defense. And of course, have a multi-domain dominance. That's what I can say in a short term.
Thank you. Thanks. And finally, a quick question to you, Professor Bala. With respect to academia, how do you think that the different policies for Skill India, and what is the way in which the policies can be framed such that we are able to catch up with the technologies typically related to strategy?
Thanks for asking this question, because this is something which is very close to my heart. Teaching has always been very close to my heart, and skilling is about teaching. And Manish also have made a mention about skilling our manpower. It's always told to us the number is our strength. Okay, that's what we always listen to. Whenever, even our Prime Minister, when he talks, he says that, it's a young country, number is our strength. But if you really look at the realities, if you think that there are about 25 odd IITs, if you think that IITs are going to solve the problem, it's not going to solve the problem. we require much larger numbers, right? And maybe 25 IITs and 25 NITs, it's not going to solve the problem. So we have about 4,500 plus engineering institutes in the country. They churn out something like 20 lakh students in a year, right? This number looks very big, but the hard reality is that, in fact, again, this is something which he was referring to. The hard reality is that more than half of them are not employable. If you really, even as a company, when we go around trying to recruit people for our development, for service, I think we get people, but if you want to people for development, it's extremely difficult to get people for development. In fact, companies like ours thrive on development. It's a product development, right? So we don't have. So basically, there is a big lacuna there. So the question is, how are we going to sort of bridge this gap? This is not limited to strategic defense. This is an area where across the board, for all the technologies that we are talking about, are going to be affected by this aspect. Now, if I look at the colleges, why the people are not employable? Because teaching is very poor. The hard reality is that teaching is extremely poor, right? So can we change the teaching quality in these institutes overnight? It's not possible. So the only way is using the online platforms, and I would say that we have done extremely well on that front. We at least have the NPTEL platform, SWAYAM platform. Now MIT also has an open web, I suppose, a platform where this technical education, the courses are offered, right? So certificates sometimes are given, but otherwise I think many of us can actually sort of attend these online lectures, and it's a very useful program. But what is happening is that the students are not, the students in the private engineering colleges and many engineering colleges, they're not taking it very seriously. So there is in fact, like I would say that the new education policy that we have, it actually puts emphasis on the use of NPTEL lectures as a part of the regular academic program. But in spite of it, I'm not sure whether it is good enough. I think we need to do a lot more, which will enforce the students to take these lectures seriously, not just the students. I believe even the teachers have to take, we should teach the teachers. I think that's also very, very important. So that is when we can really ramp up this number. We are talking about if you want to become by 2047 a developed country, we require this skill set. I think we cannot do it without the skill set. So this is one thing that's very important. The second thing that I strongly feel, this is a bit controversial, primarily because many of us are all English speaking, right? And we belong to an elitist society. If you really look at the students who graduate from the engineering institutes, right? They are either urban, mostly urban, semi-urban. But if you think that the creativity is limited only to the urban and the semi-urban region, I'm sorry, it's not so. In fact, I would like to believe that there is a lot of creativity outside this group, right? If you really want to tap on this group, right, it is extremely important that we impart science education to them in their mother tongue. I think that's extremely important. When I'm saying that mother tongue, I don't think we should start translating computer, acceleration, displacement kind of thing. I don't think we should use computer, acceleration, displacement. All of that can be used, but it has to be taught in their mother tongue. In fact, very interestingly, when I was looking at the different courses that are being offered on the online platforms, I already see that some of the tutorial colleges which are running, colleges for the civil services, and even things like Akash, they offer these lectures in both Hindi and English. They call it as English, okay? I find that it's very effective. If you really want to sort of tap on the creativity outside the group that we are talking about, I think we should put an emphasis on teaching in the mother tongue. I'm not saying that we should lose out our skill set in communicating in English, communicating in English is very important. I'm not sort of underscoring that importance, but at the same time, what is important is they should learn things in a language there. Because I have interviewed students I'm not good in Hindi, but when students come for interviews, I have interviewed them in Telugu, I have interviewed them in Tamil, okay, not for anything else. It makes them comfortable. I think this openness should be there, and that's very important for us to ramp up the skill set that we have in the country. Yeah.
Thank you, and very well said, sir. We are already at the end of the time. Can I take one question from the students? Any one question, please? Because we have ran out of time. Okay, the boy there.
Good afternoon, ma'am. My name is Sameer Chawla, and I'm from Cochrane Institute of Politics and Economics. It's an honor to meet you, and what DRDO has done for the country, I'll be extremely grateful. I just have a hypothetical question to both to ma'am and sir from DRDO. Ma'am, as of now, what news came in open source that the afterburner test for the Kaveri engine program was successful, and it's about between 81 to 83 kilonewtons. Ma'am, I have a hypothetical question regarding that. Let's assume if we want to increase the thrust of the Kaveri engine program, so what I understood for that, you need silicon carbides or ceramic matrix composites or PMC needed, and plus you have to use better metallurgy, plus turbine engine temperature needs to be increased. So I just wanted to know, ma'am, let's say T0 means if the funds have been released from the government, so how long will it take for DRDO to increase the thrust from maybe, let's say, from current 83 to maybe above 90 for the Tejas Mk2 or for the Tejas Mark 1? According to IAF, the requirements for Tejas Mk1 is between 81 to 83. So this is my question. I'm sorry, I'm a little bit too technical. If that's not an issue.
Kaveri engine, how can we
Thanks, Sameer, for asking the hypothetical question. So, do you expect a hypothetical answer also?
Sir, if you can divulge information that doesn't have an issue from country's national security.
See,
so
the aero engine for the jet, combat jet, is one of the most complex technology available with few countries: US, Russia, France, England, and now we are hearing that China has also copied it. So you are talking about the turbine blades and all. So there is a technology called single crystal blade. So now this single crystal blade technology, from the metallurgy point of view, is not available. It is being developed. So that is why, and few other sub-technologies and subsystems which were not realized. That is why this thing was not achieved. I mean, that is what I was having a info. But in details, we can always communicate to you. And, increasing the level of thrust when you are already crossed the threshold, you can understand that when you are having I will give you an analogy, when you are a 100-meter sprint, and that 100-meter sprint, if you have to cover less than 10 seconds. Now, every microsecond matters after 8. Every microsecond. And its window is very short. So, similar is the case here. When you cross threshold, the realization of technology is little different. But if, Professor, since you are working for CFD and you have interacted with GTRE, so if you want to throw some light.
We need to keep this as quick as possible because we need to get on to the next
Just
session.
a word. It's a very difficult, I think, what Manish ji has said, I think it sums up everything. It's a very difficult technology. The other thing is that the gas turbine engine is such that you cannot keep scaling it. I get this power, I want twice that, I will make the engine twice big. It's not going to work. So the engineering is extremely difficult. What you indicated is one of the critical areas where we need to make really headway, definitely. But when you look at the whole design cycle, there are delays. That's what I was referring to. There are delays. But the delays are not because of the scientists there who are working there, okay? Because I've seen that the media is extremely critical about what they do. I have great respect for what they do, and Baba Kalyani also told exactly the same thing today in the morning. Yeah.
I'm
I
really
think we
sorry,
will,
but I'm going to have to close up the panel.
Yes.
Thank you. Please give them a big round of applause.
Yeah.
And could I invite Air Marshal Gokhale to come onto the dais and give a very small memento of appreciation? And of course, we'll be thanking Dan, and we will make sure that you get one of these small mementos as well. So, first of all, to our chair of this session, Dr. Sangeeta Kale. Then to Manish Bhardwaj. Big round of applause to Professor Balakrishnan. And to Brigadier Virish Srivastav. And Dan, thank you very much for joining us from Israel. Thank you.